Hi everyone, this is Mrs. GA, and today we're going to talk about hyperbolas. So this is the geometric definition of a hyperbola. So the hyperbola is what you see the two arcs in red. So by definition, a hyperbola is a set of all points in a plane whose differences of the distances from the curve to two sets of points, which are the foci, these 2 points, is constant. So let's see if we can kind of interpret what this means. So if you pick any point on your hyperbola, and then you find the distance from that point to each of your foci. So let's call this line D1 and this line D2. The differences of those distances, so D1 minus D2, should be constant no matter what point you're working with on your graph. So for example, if you pick a point right here, if you find the difference of these two distances, it should be the same as the difference between these two distances. So again, that's the geometric definition of a hyperbola. So here are what the hyperbola equations look like and what their graphs look like. I do want to point out that these are today we're only going to be working with hyperbolas that are centered at the origin. So they're a little bit simpler than some we'll be working with soon. But there are two types of hyperbolas. So we have horizontal hyperbolas, and they look like this. So their vertices are on a horizontal axis. So the actual hyperbola, it's kind of hard to see because there's a lot going on in this graph, but is right here and right here. Okay, so the equation comes in the form of x squared over a squared minus y squared over b squared equals 1. So the biggest dead giveaway that this is no longer an ellipse is that it's a difference instead of a sum. Now, a few things to point out. A and B are always positive, and there is still a C value just like there is with an ellipse, but we have to be careful because the C value equation is slightly different than that of an ellipse. So for a hyperbola, the way you find C is by doing C squared equals A squared plus B squared. So just be careful because that's very similar to the ellipse formula, but it's a sum instead of a difference. So let's talk about what these A, B, and C values mean. So on a horizontal hyperbola, A is going to be the distance from the center to your vertex. So from here to here is A, from here to here is A. And one way you can think about it is since the A squared is under the X, A is the distance along your X axis, so horizontally. Now B is this distance from here to here and here to here. So maybe you're wondering what this little rectangular box is. So this rectangular box is what we use to help us create our asymptotes, because these graphs actually have two asymptotes where your hyperbola will travel along as it heads towards infinity. So the way that you can help determine the slope of your asymptote is actually by drawing this rectangular shape. So this rectangle, the height of it is 2b, because this distance is b, this distance is b, and the width of it is 2a. So a lot of people actually like to draw in this little rectangle, and then if you connect the corners going through, those are your asymptotes. So again, the rectangle is not really part of our graph, it just helps us to determine where the asymptotes are. So you'll notice since the asymptote is a linear equation through the center and it has a slope, we just do rise over run. So for these, your rise is B, your run is A. So you'll definitely want to take note of what the asymptote equations are. So again, for horizontal, it's B over AX. Remember, the A value tells you where your vertex is. The B value tells you half the height of your rectangle. And then C, right here, is the distance from the center to the focus. So it's the same concept as with an ellipse, but you'll notice now your C value is always going to be larger than your A value. Now when we look at the vertical hyperbola equation, you'll notice that the only thing that's different is that y squared comes first and then x squared comes second. So notice that a squared always comes first with the hyperbolas. So if y squared is the first term, then that's how you know you're going to have a vertical hyperbola. And now in this case, since a is under the y, a is the vertical distance from the center up to the vertex or the center down to the vertex. So that's our a value. Our b value is now the horizontal distance to the right or left that we can use to make our little rectangle that helps us make our asymptotes. We still find c in the same way. C squared is still equal to a squared plus b squared, except now our foci, notice, are vertical. So they're always directly above and below our two vertices. And then the other thing that's slightly different is going to be our asymptote equations, because we are still doing rise over run, but in this case, and here's the other one, in this case, our rise is a and our run is b. So in this case, the equation y equals a over b, or y equals negative a over b for the downward sloping asymptote. So again, you just have to understand what the a and b values represent. This is not necessarily something you need to memorize, because if you have your picture, you know that slope is rise over run. So you just say, okay, our rise is a, our run is b. So here again, the key is going to be to differentiate between the horizontal and hyperbola, or horizontal and vertical hyperbolas, and then being able to figure out what your A, B, and C values are and whether they are vertical or horizontal. And then one last piece of vocab. So the axis that contains your vertices and your foci is called the transverse axis. So notice on this one, it's the horizontal one. On this one, it's the vertical one. And then something, it's not drawn in this picture, but the other axis, the one that does not contain your vertex and focus, is sometimes called the conjugate axis. So those are two words you might also see popping up. Okay, so let's see if we can give one of these a try together. So here we're going to find the vertices, foci, and asymptotes of the following hyperbola, and then we're going to sketch a graph. So the first thing that you might notice is this is not in standard form for a hyperbola. We do want it to say equals 0. So our first step is just going to be to divide every term by 144 so we can put it into standard form. So this gives us x squared over 16 minus y squared over 9 equals 1. So let's walk through the different steps together. So the first thing I notice is that my x squared term comes first. So I know this is going to be a horizontal hyperbola. We can see here that a squared is equal to 16. Remember, the first denominator is always a squared. Whether it's bigger or larger, it doesn't matter. The first one is always a squared. So since a squared is 16, we know that a is 4. And since b squared is 9, we know that b is 3. And then really quick, let's also find our c value because we know that we'll need it. So remember, we do c squared equals a squared plus b squared. So just be careful. Again, this formula is very similar to the ellipse formula. So c is going to equal 5. So now we just need to talk about what the a, b, and c represent. So again, this is going to have a center at the origin. And again, we know this because we're not adding or subtracting from x or y, so it's not shifting it at all. So here's our center. I'll draw it with the blue dot. And remember, our a value, since it's horizontal, is going to be the horizontal distance to the right and left, and that's going to be where our vertices are. So I go 4 units to the right and then 4 units to the left, and those are my 2 vertices. So that's one of the things that we are supposed to list. So they're going to be at plus or minus 4, 0. Now the foci, remember, are always just beyond your two vertices, and they are 5 units from the center, in this case, whatever our C value is. So I start at the center and I go 5 units to the right, 5 units to the left, and that's where our foci are. So our foci are right there in green. And the coordinates of our foci would be plus or minus 5, 0. And now, before we can actually draw in our hyperbolas, we need to know how narrow or maybe how wide they'll be, so we're going to need to find our asymptotes. So to help us do that, we can use our B value. So remember, if you start at the center and you go your B value up and down, so I go 3 units up and 3 units down, that's going to be the top and the bottom of our asymptote rectangle. And then we already went 4 units to the right and 4 units to the left. So you can kind of turn that into your little guideline. Again, you should do it with a dotted line. And this is where our asymptotes are going to go through. So they're going to go straight through like this. And now we can follow those to actually sketch in our hyperbolas. So we have one hyperbola that follows along to the right, like this, and then one that kind of follows along to the left, like this. Now we're still going to want to write the equations of our two asymptotes. So remember, this is just a linear equation that has a slope of 3 over 4. So one of our asymptotes has the equation y equals 3 over 4x, and then the other one just has a slope of negative 3 over 4. So y equals negative 3 over 4x. And remember, both asymptotes go straight through the origin, which makes it really easy to create the linear equation. And there you have it. So now we've found everything we need, and we have a nice sketch of our graph. Okay, let's try another one together. So we're going to be finding the same things, but again, the first thing we're going to need to do is try to put this into standard form. So first of all, we should always have the constant on the right or on the other side as x squared and y squared. So we can subtract 9 from both sides, but then we also would like this number to always be a 1. So we do need to divide every single term by negative 9. So this actually becomes our positive term. So this becomes just y squared, I'll say over 1. And then this becomes our negative term, minus x squared over 9 equals positive 1. Now the reason why that I wrote it as y squared over 1 is so it looks more like that standard form. We still need an a squared term, and it's totally fine for it to be a 1. So again, I look at this, and since y squared is the first term, I know that this is going to be a vertical hyperbola. Again, the first denominator is always a squared, even if it's smaller and even if y squared comes first. So here I can see that a squared is 1, which means that a is equal to 1. Here we see that b squared is 9, so that means that b is equal to 3. And then remember, c squared equals a squared plus b squared, so c equals the square root of 10. So now we have our a, b, and c values. Again, this hyperbola has a center at the origin. And this time, again, remember, our a value is going to kind of travel along the axis that it's under. So since it's under y, it's going to travel vertically. So that means I go up 1 unit, and that's actually going to be where my vertex is, and I go down 1 unit for my other vertex. So again, a always travels along whatever variable it's under. So since it's under the y, it's going to travel vertically. We can also find where our foci are. So this tells us that we're going to go up root 10 and down root 10, and that's where our foci are going to be. So root 10 is between square root of 9 and square root of 16, so it's a little bit more than 3. So you're just going to have to estimate the best you can when you graph it. So here, 1, 2, 3, and here. And we can list those coordinates below. So our vertices this time are at 0 plus or minus 1. And our foci are at 0 plus or minus square root of 10. And again, before we can draw in our hyperbolas, which we know will be vertical, we need to know the general shape that they'll be. So for that, we need to draw in our little rectangle so we can make our asymptotes. So we already went up 1, down 1 with our a value. And then from here, we can go to the right 3 and to the left 3. And then this we can use to guide us for our asymptotes. Okay, so our asymptotes are just going to be right through here. And they would follow that same slope if you want to be a little more accurate when you're graphing. And right through here. And then you can sketch in your hyperbolas. So these are going to be really wide hyperbolas. So something like that. And there you go. We still do need to list the asymptote equations. So again, there are little formulas, or you can just say, well, what's the rise over run? In this case, for my positive slope, my rise is 1, my run is 3. So it's y equals 1 over 3x. And for the negative sloped asymptote, it's just down 1, right 3. So it's negative 1/3 x. So those are the two asymptote equations. And there you have it. All right, why don't you go ahead and pause the video and give this one a try, and then we will check your answer in just a few seconds. All right, so let's go ahead and check our answers. So here again, we need to start by dividing both sides by 3,600 to put it into standard form. Since x squared comes first, it's horizontal. A squared is 144, so A is 12. B squared is 25, so B is 5. And using our formula, we can find that C is 13. So remember, the distance from the center to each of your vertices is your A value. So I went 12 to the right and 12 to the left. It's kind of hard to see, but notice here I rescaled my graph, so I'm counting by 2s. And then for your foci, they're always along that same axis, so I'm going to go 13 units to the right and 13 units to the left to find my foci. So here's the coordinates of my vertices and foci. And then remember, we use our B value to help us make our guideline for our asymptotes. So if you go 5 units up and 5 units down, that's our little guideline rectangle, and then you can draw in your asymptotes. So you can see that my positive slope is 5 over 12 and my negative slope is negative 5 over 12. So it's going to be that B over A for the horizontal asymptotes. Okay, so now I'm going to ask you to pause the video again and give this second problem a try. All right, let's go ahead and check your work. So this is already in standard form. If it helps, you can always write this is x squared over 1. So again, y squared comes first, so we know it's vertical. A squared is 4, so A is 2. B squared is 1, so B is 1. And you can use the formula to find that C is square root of 5. So since it's a vertical one, we follow our A value. We go up 2 and down 2 from our center, giving us vertices here. And then we go along that same axis with our C value, so up root 5 and down root 5 to find our foci. And then our B value, if you go to the right one and to the left one, there's your guideline, and then that helps you draw in your asymptotes. So again, if you look at what your slope is, my rise is 2, my run is 1. So it's plus or minus 2 over 1x, or just 2x. So positive 2 for this one, negative 2 for the second asymptote. Okay, now we're going to see if we can find an equation of a hyperbola given the vertices and the foci. So here we're told that the vertices are plus or minus 3, 0, and the foci are at plus or minus 4, 0. And again, we're assuming that the center is at the origin for today. So I like to sketch a graph of this anyways because it helps me visualize what's going on. So again, if my vertices are to the right 3 and to the left 3, and then my foci are also to the right and left, we know that it must be a horizontal hyperbola. It's going to look something like this. So there's a really quick sketch just to remind us. So since it is a horizontal hyperbola, it's going to be x squared over a squared minus y squared over b squared equals 1. So we need to find a and b to finish the equation. Well, we know that a is always this distance from the center to your vertex. So we can fill that in. So again, in this case, a is equal to 3 because that's where our vertex is. So a squared in the equation, it will actually say 9. But then we still need to find our b value. From what we are given, the other thing that we do know, we don't know b, but we do know our c value, which in this case is 4. So remember the distance from the center to the focus, which here are the coordinates of your foci. So since we know our c value, we can use this formula, c squared equals a squared plus b squared, to find b. So this gives us 16 equals 9 plus b squared, and that gives us b squared equals 7. And actually, b squared is completely fine for our formula. So you don't, b would be root 7, but you're going to square it anyways, so we can just plug it right in. And this is the equation of our hyperbola. Okay, let's try one more example together. So here, again, we're going to be creating the equation, and then we also want to find the foci of the hyperbola that has vertices at 0, plus or minus 2, and then asymptotes at y equals plus or minus 2x. So let's just sketch a graph anyways so we know what type of hyperbola it is. So if our vertices are at 0, 2, and 0, negative 2 roughly, we know that we are going to have a vertical hyperbola, which looks something like this. So it's going to be y squared over a squared, minus x squared over b squared equals 1. And then again, we already know that the distance from the center to your vertex is a. In this case, it's 2, so we know that a is 2. But we still do need to find that b value. Now here, we are given the asymptote equations. So remember, the asymptote tells us the rise over run of our equations. So it's actually going to have a slope. The slope of our asymptote, at least the positive one, is 2 over 1. Now, since this is a vertical asymptote, we know that when we are finding our asymptotes, the rise is going to be a, the run is going to be that b value. So for a vertical asymptote, the slope is always a over b. So since we know that the slope is a over b and the slope is 2 over 1, we can set them equal. So 2 over 1 equals a over b. And remember, from our vertices, we know that a is equal to 2, so we can substitute that in. So 2 over 1 equals 2 over b, so that means that b must equal 1. So now we have everything we need to make our equation, so we're just going to substitute our values into this form. So that gives us y squared over a squared. Remember, a is 2, so a squared is 4. Minus x squared over 1, because b squared is just 1, so you can just leave it as minus x squared equals 1. The last thing we were asked to find are the foci of this equation. So we can use our formula. We can say c squared equals a squared, so 4, plus b squared, so c equals the square root of 5. And again, our foci are going to be vertical along with the vertices. So our foci would be directly above and directly below. And remember, they're going to be c units from the center. So it's going to be 0 plus or minus square root of 5. And there you have it. All right, so go ahead and pause the video again and see if you can give this one a try on your own, and we'll check your answers in just a few seconds. Okay, go ahead and start checking your answers. So based on the location of your vertices and your foci, we know that this is a vertical hyperbola, so y squared should come first. The distance from the center to your vertex is a, which in this case is 2. The distance from the center to your focus is that c value, which in this case is 3, but we still need to know b squared, so we can use c squared equals a squared plus b squared, substitute the values we know, and we get that b squared is equal to 5. So you substitute a squared and b squared into your formula, and you are all set. Okay, this is the last one. So once again, please pause the video and give this one a try on your own, and we'll check your answers in just a few seconds. All right, go ahead and check your answers. So here again, based on where your vertices are, we know this is a horizontal hyperbola, so it should have this form. We can also tell what the a value is based on the vertices, so a is 4. And then we are told the asymptote equation. So the slope of one asymptote is 2 over 1. We can see that right here. And for these types of horizontal hyperbolas, if you look at it, the slope of your asymptote is going to be b over a, right? Because in this case, b is a vertical distance, a is horizontal. So we know that the slope of any horizontal asymptote is b over a. So we can set 2 over 1 equal to b over a. We know that a is equal to 4, so that allows us to find that b is equal to 8. So again, we're going to plug in a squared right here, so it's 16. B squared goes here, which is 64, and then you have your equation. And then again, we're also asked to find the foci, so you can use the formula to find your c value, which is 4 root 5. So our foci, again, are going to be to the left and right of our center, so plus or minus 4 root 5, 0. Okay, that is all for today's video. Thank you so much for watching. I hope you all have a great day.